Hello dear students, a warm welcome to the Power Hour session, and today we are starting with the equilibrium chapter. So let us see the topics we will be covering. They are KPI-KC relation, properties of equilibrium constant, degree of dissociation, pH calculation, solubility and solubility product, and ultimately the buffer solution. All these subtopics we will be covering over here. So let us start with the KP-KC relation. KP and KC. Dear students, let us see first of all the derivation of Kp and Kc. We already know that in an equilibrium we will be having equilibrium constants, and these are Kp and Kc. So let us see the derivation. Suppose we are having a standard equation A gas plus BB gas giving a reversible reaction CC gas plus DD gas. Over here we are first defining equilibrium constant in terms of concentration. So I am first defining Kc. Kc is nothing but equilibrium constant in terms of concentration. Okay, so let us see what will be the Kc in terms of this equation which we are having. So Kc will be equal to concentration of C power C, concentration of D power D divided by concentration of A power A and concentration of B power B. For Kp, which is equilibrium constant in terms of pressure, simply instead of concentration we will be having the pressure terms over here. So Kp will be pressure of C power C, pressure of D power D divided by pressure of A power A, pressure of B power B. So let us have the relation. As I can see over here, we are having concentration as A and the pressure as Pa. So what is the relation between these two? We are having PV is equal to nRT, this ideal gas equation. So pressure is equal to N by V RT, and N by V is nothing but concentration. So we can simply write pressure of A is equal to concentration of A into RT. So the relation between Pa and concentration of A is pressure of A is equal to concentration of A into RT. Similar over here, concentration of B and Pb, concentration of C and Pc, concentration of D and Pd. The relation between all of them will be pressure of B is equal to concentration of B into RT, pressure of C is equal to concentration of C into RT, and pressure of D is equal to concentration of D into RT. Okay, so simply put the values in this. We can put all these values in the Kp and let us see what we will get. So instead of Pc I am writing down concentration of C into RT the whole power C, concentration of D into RT the whole power D divided by concentration of A RT the whole power A and concentration of B into RT the whole power B. So you can see we are getting concentration of C power C, concentration of D power D divided by concentration of A power A, concentration of B power B into this RT I am taking outside. In the numerator you are getting RT power C plus D, in denominator RT power A plus B. So ultimately we are getting RT power C plus D minus A plus B. And this is nothing but Kc. So we are having over here the Kp is equal to Kc into RT the whole power C plus D minus A plus B. In thermodynamics, we used to study about a term called delta Ng. So the delta Ng is nothing but summation of stoichiometric coefficient of gaseous product minus summation of stoichiometric coefficient of gaseous reactant. So you can see over here that delta Ng, this C plus D minus A plus B, for this equation C plus D minus A plus B is nothing but delta Ng. So instead of C plus D minus A plus B, for generalizing, I can write it down as Kp is equal to Kc into RT power delta Ng. So this is the relation between Kp and Kc. Kp is equal to Kc into RT power delta Ng. So we derived this equation, and let us see the question, type of questions they are asking from this. The ratio of Kp by Kc for the reaction CO gas plus half O2 gas giving CO2 gas is. So simply you have to calculate the delta Ng value. Delta Ng summation of stoichiometric coefficient of gaseous product minus summation of stoichiometric coefficient of gaseous reactant. So here we are having stoichiometry 1 minus here 1 plus half 3 by 2. So we are having minus half as the delta Ng. Delta Ng is minus half. So Kp is equal to Kc into RT power delta Ng. So put the value Kp is equal to Kc into RT power minus half. So we are getting a ratio we want now. Kp is equal to Kp upon Kc. We are getting RT power minus half. RT power minus half. RT power minus half. So this is the answer, D option. Okay. Next. So let us see the different type of questions they are asking related to Kp and Kc. Many times what they will do, they will give a reaction. Suppose dissociation is happening, PCl5 gas is there. Initially you are having only PCl5 gas. Okay, it is having pressure P nod. Okay, but you know what will happen? PCl5 will dissociate into PCl3 plus Cl2. This PCl5 gas will dissociate into PCl3 gas and Cl2 gas. So finally what will happen? We will be having in the vessel PCl5 gas as well as PCl3 gas as well as Cl2 gas. We are having all the three gases. So the final pressure will be, the pressure final will be having pressure of PCl5 plus pressure of PCl3 plus pressure of Cl2. All the three pressures will be there. So how question they will ask? They will ask at time 0 we are having some pressure, that is P nod. The pressure of PCl3 and Cl2 will be 0. And finally also at equilibrium they will give us a pressure, the P value will be given, that P will be equal to, this final pressure will be equal to pressure of PCl5 plus pressure of PCl3 plus pressure of Cl2. Okay, pressure of Cl2. So the final pressure also we will be having, but it will be P naught minus X, X and X. So they will be giving both the information, the P naught information also given and the pressure final, that is P, the information, both informations will be given. From there we can get the X value and ultimately we will solve it to get X value as well as P naught value will be initially given over there, and then we will find the Kp value which will be asked in the question. The question will be asking about the Kp value. So let us see what type of question they are asking. So let us see by this question. XY2 dissociates as XY2 gas plus giving XY gas plus Y gas. Initial pressure of XY2 is 600 mm of Hg. The total pressure at equilibrium is 800 mm of Hg. Assuming volume of the system to remain constant, the value of Kp is. So as I said you, XY2, first of all write down the equation. XY gas plus Y gas. Okay, time 0, at time 0 we are having the pressure as 600. So the P naught value they have given over as 600, and the pressure due to XY and Y will be 0. Finally at equilibrium what we are having, pressure equal to 800. So this is 600 minus X and X, because the stoichiometry is 1 1. So this total pressure is equal to 800. That is the P value they have given over there. 800 is equal to 600 minus X plus X plus X. So we are having 800 is equal to 600 plus X, and from here we got the X value. The X value we got is 200. So again we have to put the value over here. X value 200 put over here. We are getting this 400, and this is 200, and this is 200. Okay, so now you can find the Kp. Kp will be pressure of XY into pressure of Y divided by pressure of XY2. So we are getting how much, beta? 200 into 200 divided by 400. So this is how much? 40000 divided by 400. 20 got cancelled. 400s are 400. So it is 100. So we are getting 100 as the answer. Same type of question they are asking every year. Similar type of questions they are repeating. Same type of question they asked. The initial pressure of COCl2 is 1000 torr. The total pressure of the system becomes 1500 torr when the equilibrium COCl2 gas giving CO gas plus Cl2 gas is attained at constant temperature. Similar type of question. So same concept you have to apply. First of all write down the equation. COCl2 giving CO plus Cl2. Of course all of them are gas. At time 0 the pressure, initial pressure is 1500. Of course it will be only of COCl2, and these two are 0 0. At finally we will be having 1500 minus X, X and X, and the total pressure they have given over here how much it is. They have given over the final pressure is 1500, and okay, the initial pressure was 1000 and final pressure is 1500. Initially 1000, so 1000 minus X, and the final pressure is 1500. So the final pressure is 1500, that is the P value is equal to 1000 minus X plus X plus X. So we got 1500 is equal to 1000 plus X. From here we got the X value. X value is equal to 500. Put the X value over here. We are getting this as 500, 500, 500. So the Kp value we have to find. The Kp will be pressure of CO into pressure of Cl2 divided by pressure of COCl2. So we are getting 500 into 500 divided by 500. So ultimately the Kp value we got is 500. That is the option D. So this type of question they are asking. So this was about Kp and Kc, and the relation between Kp and Kc is Kp is equal to Kc RT power delta Ng. So let us move to the next section now. That was our property of equilibrium constant. So let us move to the next section. Properties of equilibrium constant. Properties of equilibrium constant. See, we are talking about the three properties the three important properties. Every year they are asking question, and sometimes the three properties, all the three properties are brought together in the question. We have to apply all the three properties one by one, all the three properties. First of all, the first property I am writing down. If a reversible reaction, having equilibrium constant equal to K is multiplied by a number n, then the new reversible reaction thus obtained has equilibrium constant equal to K power n. Means if the reversible reaction initially they have given has equilibrium constant K, and you are multiplying it by 2, suppose you are multiplying the whole equilibrium equation by 2, then the new reversible reaction that will be obtained will have equilibrium constant equal to K power 2. Okay? If you are multiplying by a negative value, what will happen? See, then one more thing will happen. The reactant will become product and the products will become reactant. And the new equilibrium constant, you can get it, of course. For example, if you are multiplying by -2, then the new equilibrium constant will be equal to K power -2. But one thing I mentioned over here, that if you multiply a negative value, then the reactants will become product and the products will become reactant. Okay? I am giving you example over here. Suppose you are having PCl5 giving PCl3 plus Cl2. All of them are gas, of course. And it has equilibrium constant equal to K. And if you are multiplying it by 2, then the new equilibrium PCl5 giving 2 PCl3 plus 2 Cl2. This equation will be having equilibrium constant equal to K power 2. And if you are multiplying by negative value, so one more thing will happen over here. The reactant will become product and product will become reactant. So you will get 2 PCl3 plus 2 Cl2 giving 2 PCl5, and the equilibrium constant will be equal to K power -2. So this is our first property. Now let us see the second property. The second property says, if you are having two reversible reactions, one is having equilibrium constant equal to K1 and another is having equilibrium constant equal to K2. If these two reversible reactions, if they are added, then the new reversible reaction thus obtained has equilibrium constant equal to K1 into K2. So in simple words, I can say that if you are adding two reversible reactions, then their equilibrium constant will multiply. Okay? If two reversible reactions having equilibrium constant equal to K1 and K2 respectively, if these two equations are added, then the new reversible reaction, then the new reversible reaction thus obtained has equilibrium constant equal to K1 into K2. Okay. So I am giving an example over here. Suppose you are having a reaction SO3 gas giving SO2 gas plus half O2 gas. It has equilibrium constant equal to K1. Okay. And the another equation you are having NO gas plus half O2 gas giving NO2 gas. This reversible reaction has equilibrium constant equal to K2. See, if these two are added, what will happen? If these two are added, half O2 will get cancelled and the equation obtained will be SO3 gas plus NO gas giving reversible sign SO2 gas plus NO2 gas. Okay. So this reversible reaction will be having equilibrium constant. Suppose I am taking as K dash. This K dash will be equal to K1 into K2. So this is the second property. I have given example also. Let us move forward. Now I am talking about the third property. And it says, see, if you are adding, then there is a simple case. You add 1 plus 2 or 2 plus 1. They are same. But if you are subtracting, so 1 minus 2 is different and 2 minus 1 is different. Let us see the importance of this. This statement I am giving you is very important. You have to see whether you are subtracting 1 minus 2 or 2 minus 1. Because, dear students, in this third property, we are talking about subtraction. If they are given you two reversible reactions having equilibrium constant equal to K1 and K2, and if you are subtracting them, suppose you are subtracting 1 minus 2, then the new reversible reaction thus obtained will be having equilibrium constant equal to K1 by K2. But if you are subtracting 2 minus 1, then it will be having equilibrium constant K2 by K1. So there is a difference, okay? But in addition, simply if you add 1 plus 2, then also K1 into K2, 2 plus 1, then also K1 into K2. But in subtraction, you have to remember this, that check whether we are having 1 minus 2 or 2 minus 1. So let us see the third property. If two reversible reactions having equilibrium constant equal to K1 and K2 respectively, if they are subtracted such that 1 minus 2, then the new reversible reaction thus obtained has equilibrium constant equal to K1 upon K2. Let us see example over here. Suppose we are having two equations, SO2 plus half O2 giving SO3 gas, and NO plus half O2 giving NO2 gas. This is having equilibrium constant equal to K1 and this is having equilibrium constant equal to K2. If I am subtracting such that 1 minus 2, what will happen? This half O2 will get cancelled. It will be SO2 plus NO2 giving SO3 plus NO. And this will be having equilibrium constant. Suppose I am taking it as K dash. This K dash will be equal to K1 upon K2. Okay. So this is the third property. So we covered all the three properties. Now let us see the questions that they asked. Let us see one by one. So this is the question. Sulfide ion reacts with solid sulfur. Two equations they have given. The equilibrium constant for the formation of S32 minus from S22 minus and sulfur is. So they are asking us the equilibrium constant for the reaction. You can simply see for the formation of S32 minus and from whom? From S22 minus. So in the product side you should have S32 minus. In the product side we should have this S32 minus, and in the reactant side we should have this S22 minus. From this we are coming to know that this reaction will remain as it is, but we have to subtract this one because this S22 minus we want it on reactant side. Okay. Why we want? See, they have said formation of S32 minus from S22 minus and sulfur, but I am writing only this one to show you that how to approach this S32 minus. We want it on product side. This S22 minus we want it on reactant side. Simply I told you, if you subtract, if you apply minus, then the product become reactant and the reactant become product. So simply we can see this is equation 1, is this equation 2, and the equation that we want. Suppose I am writing over here, the equation we want is S3 2 minus, we want from S2 2 minus and S. This equation we want. Okay, this equation we want, and for this we can simply see that we have to do 2 minus 1. If you take 2 minus 1, what will happen? This 2s minus s, 1s will remaining, this s2 minus will get cancelled, and this s22 minus will go off from product side to the reactant side, and we will get this equation. So simply you can see we subtracted 2 minus 1, so the new reversible reaction thus obtained will be having equilibrium constant equal to K2 upon K1, and the K2 value we have 130 upon 10, so we are getting 13 as the answer. So B option will be the answer. Okay, let us see one more question. So this is the question they asked. For the reaction N2 gas plus O2 gas giving 2NO gas, the equilibrium constant is K1. The equilibrium constant is K2 for the reaction 2NO gas giving O2, 2NO plus O2 giving 2NO2 gas. What is the K for the reaction NO2 gas giving half N2 plus O2? See, to solve this type of question, the important approach you should have, write down the given equations above and the required equation below, and see, check which properties you have to apply. So I am first of all writing down the equations. N2 gas plus O2 gas giving 2NO gas. Okay, this is having equilibrium constant equal to K1. And the second equation, we are having 2NO gas plus O2 gas giving 2NO gas, 2NO2 gas. This is equation number 2. And the equation that we want, write it down over here. What the equation we want? NO2 gas giving half N2 gas and O2 gas. So let us see which properties we will have to apply. See, I can see over here that this N2 is on the reactant side over here and it is in the product side over here. So simply we know that this is only possible if you are subtracting it by, or you are having multiplied this by minus. Either you will subtract this so that minus sign will go over here, or I can say if you are multiplying by minus, then the reactant will become product. So this N2 is coming on product side. It signifies that this is getting subtracted. The first equation is getting subtracted. Okay. O2. This O2 is also over here. Okay, that we will see. This NO2. This NO2 was on the product side and it got to the reactant side. So definitely this NO2, I can see over here, this is also subtracted. It is multiplied by a minus sign. That's why this NO2 from product side came to the reactant side. Okay. So let us see how to approach. I can simply say I am multiplying this by minus half, also this by minus half. Let us see what will happen if you multiply both of them by minus half. You will get NO gas giving half N2 plus half O2, and the equilibrium constant for this will be equal to K1 power minus half. We are also multiplying this by minus half because I want this 2NO2 to come from product side to reactant side, as well as it gets from 2 to 1. So that's why I multiplied by minus half. This we are getting NO2 gas giving NO gas plus half O2 gas. Okay. So now let us see, we are having NO2 on the reactant side and we want this NO to get cancelled. Simply by adding these two, we can get that equation. See, you can see over here, this NO2 will be on the reactant side. If you add this NO gas will get cancelled, and this half O2 and half O2 add, it will get the half plus half 1 O2. Okay, so simply I can see, simply we have to add these two equations. This is having K1 power minus half and this is also having K2 power minus half as the equilibrium constants, and now on adding we are getting this equation NO2 giving half N2 plus O2. We are getting by addition of these two. So the equilibrium constant K dash will be equal to K1 power minus half, K2 power minus half. Or you can say simply 1 upon K1, K2, the whole power half. 1 upon K1, K2, I can see the fourth option, 1 upon K1, K2, the whole power half. So this is the answer. Okay. Next question, let us see. This is also PYQ question. The following equilibrium constants are given. For the first equation it is K1, for the second equation K2, and the third equation K3. The equilibrium constant for the oxidation of NH3 by oxygen to give NO. See, this question was asked 2 times. In the AIMS they asked this question. Same question over here we are having, and in the NEET also they asked this equation, but in that they made it easy. They gave the equation over there, but in this I have taken the difficult one, that is the AIMS question which they are having. They have not given the equation. We have to write down the equation. So of course we will write down, no issue. Let us write down the equation that we want. So we are having oxidation of NH3. Okay. So NH3, we having NH3 over here, 2NH3 plus O2 giving giving NO plus H2O. So let us balance. We are having 6 hydrogens, so either 3 hydrogens and 2 nitrogens, so here 2 nitrogens. And now we can see how many oxygen? We are having 2 plus 3, 5. So we will be having 5 by 2 over here. So 2NH3 plus 5 by 2 O2 giving 2NO plus 3H2O. This is the equation of which we have to calculate the equilibrium constant. In the NEET exam, they asked this question. Along with this, they gave this equation also. So in the NEET exam, they made it easy. But in the AIMS exam, they didn't give the equation. This is the same question from the AIMS examination. So let us see how to get this equation from these 3 equations. Simply I am writing down over here N2 plus 3H2 giving 2NH3. Equilibrium constant is K1. Next, N2 plus O2 having equilibrium giving 2NO and equilibrium constant K2. H2 plus half O2 giving H2O having equilibrium constant K3. So as I told you how to approach, write down the equations above which if they have given and the required equation below like this, and see how to get this from them. So I can see the 2NO we want on the product side is here on the product side only. The 2NH3 that we want is on the product side over here, but we want it on reactant side. So simply it must be subtracted. That's why this 2NH3 will come from product side to the reactant side. One more thing I can see, we want 3H2O and we are having only 1 H2 over here. So first of all, we have to multiply this by 3. If you multiply them by 3, what will happen? This will get 3H2, 3 by 2O2, and this will become 3H2O, and the equilibrium constant will become K3 to the power 3. And we want this 3H2 on the product side only. So simply now we can see just we have to add these two and subtract this, we will get this equation. You can see if you add this and subtract this. Subtract means we have to simply write down minus over here. Okay, so this N2 will get cancelled. You can see over here, yes or no? This H2 will get cancelled and we are getting the equation 2NH3 will come from that side to this side, 2NH3 plus 5 by 2O2 giving 2NO plus 3H2O. So simply we are adding these two and subtracting this. So what will happen? This will be having equilibrium constant. Suppose K dash will be equal to, these two are getting added. So they will multiply K2 into K3 power 3 and this will get divided. So the K1 will be in the denominator. So the equilibrium constant we got is K2, K3 power 3 upon K1. So B option will be the answer. So this way you can see we have to solve all these type of questions. So let us move forward to the next section. We studied about the equilibrium constant properties. Now we are talking about the degree of dissociation. That is our third subsection. Let us move forward now. Now we are talking about the third subsection, that is degree of dissociation. Degree of dissociation. So let us first define it. What is the definition of degree of dissociation? So degree of dissociation actually defines the fraction of reaction completed. Steve, suppose you say half of the reaction is completed. So the degree of dissociation value will be equal to half, 1 by 2. So it defines degree of dissociation. It defines the fraction of reaction completed. It is denoted by, generally it is denoted by alpha. And mathematically, so let us see how mathematically we are having this alpha. Simply reacted divided by initial. The amount which is getting reacted, you write it down on the numerator and write the initially taken value in the denominator, you will get the alpha value. So let us see questions based on this. So let us see the questions based on degree of dissociation. So this is the question: for which of the following reaction the degree of dissociation alpha, equilibrium constant Kp are related as Kp is equal to 4 alpha square P upon 1 minus alpha square. Always we have to remember this, that this P pressure is not the initial pressure, it is the pressure at equilibrium. Many times they have asked the questions and sometime they will inform you that P is the pressure which is equilibrium pressure, but sometimes they will not mention, but you have to remember this, that the pressure P is equilibrium pressure. So let us see. Suppose checking this first equation whether it is having this relation or not. N2O4 gas giving 2NO2 gas. At time 0 we are having P0 as the pressure of N2O4 and this is 0. At equilibrium, what will happen? P0 minus x and this is 2x. Now I taught you how to write down the alpha. Alpha is nothing but reacted. How much got reacted? X divided by initial. Initial is P0. So instead of x, you can write down P0 alpha. Instead of x, I can write down, so this will be nothing but P0 minus P0 alpha. You can say P0 into 1 minus alpha. And this will be equal to 2 P0 alpha, okay? This will be equal to P2 P0 alpha. So let us see the Kp value. Kp is nothing but pressure of NO2 square divided by pressure of N2O4. 2 P0 alpha square divided by P0 into 1 minus alpha. So we are getting 4 P0 alpha square upon P0, this is also square, P0 into 1 minus alpha. 1 P0 is getting cancelled. We are getting 4 P0 alpha square upon 1 minus alpha. But as I said that this P, we want the Kp relation in terms of P, not P0. So let us see what is the relation between P and P0. So the P is the actual equilibrium pressure, addition of these two. This P will be equal to P0 into 1 minus alpha plus 2 P0 alpha. So we are getting P equal to how much? P0 plus P0 alpha. So we are getting P is equal to P0 into 1 plus alpha. So instead of P0, I can write it down. P0 will be equal to P upon 1 plus alpha. So instead of this P0, I can write it down P upon 1 plus alpha. You will get 4 P alpha square upon 1 minus alpha into 1 plus alpha. It will be 1 minus alpha square. It will be 1 minus alpha square. So we are getting Kp is equal to 4 P alpha square upon 1 minus alpha square. So definitely first option is our answer over here. Okay. We got the relation as Kp is equal to 4 alpha square P upon 1 minus alpha square for this first equation. You can check for other equations also, but as we have got in the first option only, we have got the answer. Okay. So let us move forward now. Let us move forward. Yeah, this is the question. This is the question we are talking about. At temperature T, a compound AB2 gas dissociates according to the reaction 2AB gas giving 2AB plus B2 with a degree of dissociation X, which is small as compared to unity. The expression for Kp in terms of X and total pressure is. This is a PYQ question, very important one. They've asked us the expression of for Kp in terms of X, and this X is nothing but alpha only, degree of dissociation. Okay, so we will solve it by having the degree of dissociation equal to X. You can simply do it in the last section, the last point. You can change it from alpha to X. So let us first solve it. So we are having this equation 2AB2 gas giving 2AB gas plus B2 gas. This is the reversible reaction, and at time 0, this is having pressure P naught 0 0. At equilibrium we are having this P naught into 1 minus alpha. This is P naught alpha and this is P naught alpha by 2. Okay. So let us see what Kp value we are getting over here. Kp is equal to P naught alpha into P naught alpha square into P naught alpha divided by 2 upon P naught into 1 minus alpha square. Simply you already know this Kp will be pressure of AB square, pressure of B2 divided by pressure of AB2. Okay. So this we are solving over here. Kp is equal to the whole square. Yeah. So the P naught square alpha square into P naught alpha divided by 2, the whole divided by P naught square into 1 minus alpha square. So this P naught square got cancelled over here. P naught square, and we are getting simply the Kp equal to how much we are getting? P naught alpha cube divided by 2, the whole divided by 1 minus alpha the whole square. See, they have said that the degree of dissociation is much smaller as compared to unity. They have said it. So that means 1 minus alpha will be equal to 1. So I can write it down, P naught alpha cube the whole divided by 2. In this, one more thing is also there. As I told you, we have to take P instead of P naught, and the P is total pressure. So the total pressure P, I am getting the relation between P and P naught. So let us see what is the total pressure P equal to. Addition of the 3. The addition of the 3 will be P naught into 1 minus alpha, P naught alpha. This P naught alpha will get cancelled and you will get P naught alpha, P naught plus P naught alpha by 2. So we are getting P naught into 1 plus alpha by 2. And as I told you, this alpha is much less than 1. So 1 plus alpha by 2 will also be equal to 1. So this P and P naught are equal for this question. So instead of this P naught, I can write it as P. So P alpha cube divided by 2. And as I told you in the last, we have to put alpha is equal to x. So P x cube divided by 2. This is the Kp value we got. So the answer will be Px cube divided by 2. Px cube divided by 2. The first option will be the answer. Okay. This is one more question in PYQ. It is a very important question. Let us see. The value of Kp1 and Kp2 for the reaction x giving y plus z and a giving 2b are in the ratio 9:1. So the Kp1 upon Kp2 value they have given over here. Kp1 upon Kp2. How much? 9/1. If the degree of dissociation x, okay, they have given the degree of dissociation for X and for A are equal, means for this both the equation reactions the alpha value is same. Okay, then the total pressure at equilibrium 1 and 2 are, so they are asking us that the total pressure equilibrium in this first one and the second one, the ratio of their total pressure at equilibrium, what is the value they are asking. So let us see standard method we have to follow, x giving y plus z and a giving 2b. These are the two equations. This is having initial pressure P naught 0 0 times 0, and at equilibrium we are having P naught into 1 minus alpha, and this is P naught alpha, P naught alpha. Over here the same thing, times 0, P naught 0, and at equilibrium we are having P naught into 1 minus alpha, and this is 2 P naught alpha. Okay. So Kp1 will be equal to how much beta? Kp1 will be equal to how much we are getting? Add up P naught alpha into P naught alpha divided by P naught into 1 minus alpha. P naught is getting cancelled. So Kp1 is equal to P naught alpha square divided by 1 minus alpha. And Kp2, we are getting over here how much? 2 P naught alpha whole square divided by P naught into 1 minus alpha. So we are getting 4 P naught square alpha square divided by P naught into 1 minus alpha. So this P naught is getting cancelled. We are having 4 P naught alpha square upon 1 minus alpha. If you divide both of them, if we are having Kp1 upon Kp2, see what will happen? This P naught will get cancelled, and we are having 1 minus alpha we also cancel. All getting cancelled, only 4 we are having. 1 upon 4. As I can see, 1 upon 4. You can see P naught also cancelled, alpha square also cancelled, 1 minus alpha also cancelled. Kp1 upon Kp2, we are getting it as 1 by 4. And we are having this Kp1 upon Kp2, we divided it, and we are having this as P1 naught and this as P2 naught. So P1 upon 4 P2 we are getting over here, 4 P2. This is P1 naught I am taking over here, and this is P2 naught. So we are having Kp1 upon Kp2 equal to P1 upon 4 P2. And one more thing, if you add all of them, you can see we are getting that P1 equal to, suppose this is the P1 is the total pressure and P1 is the total pressure at equilibrium, we are getting equal to how much? We are getting it as P naught, yeah, or you can say P1 naught. And if you add over here, this P2 is getting equal to P2 naught. So you can see that instead of this P1 naught, I can simply write P1, and instead of this P2 naught, I can simply write P2, because the same thing is happening over here. As you saw in the last question, here the total pressure, that is I am taking as P1, is equal to the P1 naught value, and this total pressure P2 is equal to the P2 naught value. So simply we are getting this Kp1 upon Kp2 is equal to P1 upon 4 P2. So they are asking us P1 upon P2. So how much will be the P1 upon P2? This 4 getting multiplied over here, 4 into Kp1 upon Kp2. And what is the Kp1 upon Kp2 value they have given? 9 by 1. So put the value 9 by 1 over here. We are getting 36 upon 1. So the answer will be 36 upon 1. The fourth option will be our answer. So this is also a good question they asked. Let us continue. So next see the pH calculation. See the pH calculation. We are having many sections in this pH calculation. where we will be starting with for water at 298 Kelvin. If we are having pure water, pure, so simply H2O dissociates into H plus and OH minus. This is aqueous, okay, liquid, and these two are aqueous. So as you can see, we are defining our equilibrium constant for water, that is Kw. It will be H plus concentration into OH minus concentration, and the active mass for liquid, pure liquid, is 1. So H2O concentration is 1, that no need to write. So this Kw, when they solve this at 298 Kelvin, the Kw value came out 10 to the power minus 14. So 10 to the power minus 14 is equal to H plus concentration into OH minus. For pure water, both will be equal. So for pure water at 298 Kelvin, for pure water 298 Kelvin, this H plus concentration square will be equal to 10 to the power minus 14. So the H plus concentration will be equal to 10 to the power minus 7. So pure water, you can see the pH scale will be from 0 to 14, and this 7 will be neutral. 7 will be our neutral point. If you add acid from outside, then the value you will get will be this 10 to the power minus 7 value will increase to 10 to the power minus 6, 10 to the power minus 5, and then after that we will take H is equal to minus log of H plus concentration, put the value of H plus, you will get this 0 to less than 7 value for the acidic. So this is acidic medium and this is basic medium, but this is only for 298 Kelvin. If you are changing the temperature, if you look at this reaction, this is a endothermic reaction. This is a endothermic reaction. So if you increase the temperature, if temperature is increased, the Kw value will also increase. From 10 to the power minus 14, you will get to 10 to the power minus 13, 10 to the power minus 12. So the pH scale will go from 0 to 14, it will become 0 to 12. By changing the temperature, if you are increasing the temperature, the Kw value will change, the pH calculation will change, and even the neutral point will change. So pH is equal to 7 is only neutral for at 298 Kelvin. Okay, this is a very important point. So let us see how to calculate the pH for this type of questions. Let us see. Yeah, the pH of 10 to the power minus 11 molar HCl. This is a very good question. See, water itself gives how much? As I told you, H2O pure will give H plus equal to 10 to the power minus 7 at 298 Kelvin, that is 25 degrees Celsius. And if you are adding very little amount of HCl, very little, how much? Suppose in 1 liter you are adding 10 to the power minus 11 moles of HCl. Okay, so that means this is very much negligible as compared to the H plus that is given by water. So in this we have to take H plus from water as well as H plus from HCl. In this we have to consider H plus from water. That will be our overall H plus overall. So we are getting this H plus overall. How much we are getting? Simply add these two. The H plus overall we are getting over here is 10 to the power minus 7 plus 10 to the power minus 11, and it will be just more than 10 to the power minus 7. So the pH, see, pH is a minus log of H plus. So if you put a value that is more than 10 the power minus 7, suppose towards 10 the power minus 6. So this will be, pH will be slightly less than 7. It will be slightly less than 7. So the answer will be our fourth option. Okay. So you have to think that H plus you have to take it from water also if we are having so less amount of HCl. Otherwise you will get a very bad, or you can say joke like answer. Like if you are having directly minus log of this value, you will get pH equal to 11. If you are adding HCl and you are getting pH 11 base, that is the basic medium. This is not possible. So remember, in such situations you have to take H plus from water also. At 100 degrees Celsius, Kw is 10 to the power minus 12 pH of pure water at 100 degrees Celsius will be. So this question you can see the Kw value has changed. It has increased because the temperature has increased. So for this, as I told you, the pH scale will be from 0 to 12 and the midpoint, that is 6, will be the pH. Okay. So the answer will be second option. Okay. So let us see the next section which we will be covering over here. Solubility and solubility product. See, sparingly soluble salts. We are talking about sparingly soluble salts. What are they? They are very less soluble in water. They will give reversible reaction, reversible dissociation reaction. For example, if we are having any salt AXBY, this is a sparingly soluble salt. If you are putting it in water, what will happen? This AXBY solid will dissociate into XAY plus and YBX minus. Okay. This is having active mass 1, but this will be having XS and YS as their concentration, where S is nothing but this S is solubility. And then after that, see, for every reversible reaction, as it obtains equilibrium, we are having equilibrium constant. And here the equilibrium constant will be Ksp. This is our solubility product. Solubility product. Okay. So this solubility product Ksp, we call it as, it will be equal to how much beta? It will be equal to A concentration power X and B concentration power Y. So it will be XS power X and YS power Y. It will be X power X, Y power Y, S power X plus Y. So this is the equation. This is for a general salt of the kind AXBY. We will be having the relation between solubility and solubility product. The relation will be X power X, Y power Y, S power X plus Y. Okay. Suppose like you are having AgCl. So if you compare this with AXBY, it is a AB type of salt. AB type means X is equal to 1, Y is equal to 1. So the Ksp and S relation for AgCl will be simply put X equal to 1 and Y equal to 1, 1 power 1, 1 power 1, S power 1 plus 1. We are getting Ksp equal to S square. Okay. So let us see the question regarding solubility product and solubility. If the solubility of Al2SO4 thrice is S, then its solubility product is. So this is which kind of salt? This is A2B3 type of salt. So put simply x value equal to 2 and y equal to 3, in the relation KSP is equal to x power x, y power y, s power x plus y. Okay. So simply put the value over here. We are getting KSP equal to 2 power 2, 3 power 3, s power 2 plus 3. We are getting 4 into 3 cube. 3 cube is 27. So we are getting s power 5. 27 into 4 will be 108. So we are getting 108 s power 5. So it will be 108 s power 5. So this is the questions they are asking. They are asking different questions also. But I am covering all the sections. I am trying to cover all the section and we are having limited time. So let us move forward to the buffer solution. So what is the buffer? Buffer. See, buffer is a solution which follows the Lee-Chatelier principle. In Lee-Chatelier principle, we used to study that if you put an external, any quantity of acid, base or any other thing which hurts the equilibrium, then their Lee-Chatelier principle is followed. It always resists. So here also buffer. What is a buffer solution? A buffer solution is a solution which resists the change in pH. It is a solution which resists change in pH. So here we will be focusing on two type of buffers: acidic buffer and basic buffer. Acidic buffer and basic buffer. Okay. See, acidic buffer, how we will produce this acidic buffer? By having weak acid is added some quantity of strong base. One thing you have to understand, if this is having N1 moles, this is N2 moles, N1 should be greater than N2. This is a very important thing. Here weak base and strong acid. You have to understand, you are adding weak base, strong acid. Here N1 moles, here N2 moles. Here N1 is greater than N2. If you have N1 greater than N2, then only buffer will exist. The point N1 equal to N2, it will become a salt hydrolysis. So very important point. This is preparation. This is preparation of them. And finally what will happen? Finally you will be having in this weak acid, it was more in quantity, so weak acid, and this strong base, it was less in quantity, it was limiting reagent, so it got exhausted and we have only salt now, weak acid and salt. This will be having similarly weak base and salt. Weak base and salt. So this is acidic buffer, this is basic buffer. And also they are having most of the question related to formula pH calculation. So in acidic buffer, if you see the acidic buffer pH calculation will be pKa plus log of salt concentration upon weak acid concentration. And for basic buffer, we are having pOH. First of all, we will calculate the pOH, which will be equal to pKb plus log of salt concentration upon weak base concentration. And then after you can apply pH is equal to 14 minus pOH. And of course at 298 Kelvin you can apply this. So let us see a question for this buffer. So this is the question. Solution of 0.1 normal NH4OH and 0.1 normal NH4Cl has pH 9.25. Find out the pKb value. So from here you can see it is a basic buffer, and For both of them, the n factor is equal to 1. So this is nothing but 0.1 molar, and this is also 0.1 molar. Because both of are having n factor equal to 1. If n factor is 1, normality is equal to molarity to n factor. The n factor is 1, normality and molarity are equal. So this is a basic buffer, and pOH will be equal to plus log of salt concentration upon weak base concentration. So both of them are equal 0.1, 0.1. So this will get equal to log of 1, and log of 1 equal to log of 1 is equal to 0. So here pOH is equal to pKb we are getting. And also they have given us the pH. So pOH is nothing but 14 minus pH. So we are having 14 minus 9.25, that will be equal to 4.75. So pOH is equal to 4.75. So pKb we got 4.75. So this is B option, 4.75. So we covered here many of the subsections, all subsection that we had to cover in this 1 hour session. Already we have given more than 1 hour, because see, equilibrium chapter is a very big chapter, but we are trying to have most of the sections covered over here. So let us meet in the next section. Hope you all enjoyed. So let us meet in the next power hour session. Thank you so much. Bye dear students.